Okay, this video is the second part of precipitation reactions. Let's have another example in this video. So when an aqueous solution of silver nitrate is added to an aqueous solution of potassium chloride, a white precipitate forms. So we saw in the first video that when we mix two different aqueous solution, and when we mix it, one of the product will be the solid form or the precipitate. We call it a precipitation reaction. So the reactants are two completely aqueous solution, but in products we have one solid phase. So that's why we call it precipitation reaction. So here we have the same thing. We have silver nitrate here, and we have potassium chloride here. If we know when we mix these two, we're gonna get a noun white solid. So let's see what are the ions we have. So we said last time that when we have aqueous solution, and since there are strong electrolytes, this compound is going to be dissociated into cation and anion. So here we have silver and nitrate, and here we have potassium and chloride. And these are the combined solution before reaction. So we have these four ions, two cation and two anions. And here is the picture. As you see here, the reactants are completely clear. We have complete solution, aqueous solution. We have potassium and chloride, and here we have silver and nitrate. And while we're mixing, we're gonna form a precipitate here. We need to know what is this precipitate here. So possible compounds. So since we have all these ions, we can have different compounds. These possible compounds are silver nitrate, potassium chloride, silver chloride, and potassium nitrate. So as we saw here in the reactants, we have silver nitrate and potassium chloride. So we can cancel these two because these are the reactants, so they are not possible. So the real compounds are AgCl, which is silver chloride, and KNO3, which is potassium nitrate. So KNO3 or potassium nitrate is quite soluble in water, so that's the product must be AgCl. So from these two, this one is completely soluble, so the precipitate must be AgCl. So as you see here, AgCl is S phase, and we have potassium nitrate. So let's have some rules to know which compound is soluble and which compound is not soluble. So most nitrate salts are soluble. Most salts containing the alkali metal ions such as lithium, sodium, potassium, cesium, rubidium, and the ammonium ion are soluble. Most chloride, bromide, and iodide salts are soluble. Notable exceptions are salts containing the ions silver, Pb, and Hg, which is mercury. Most sulfate salts are soluble. Notable exceptions are BaSO4, PbSO4, and HgSO4, and CaSO4, which is calcium sulfate. Most hydroxide salts are only slightly soluble. I'm going to explain what does that mean, slightly soluble. The important soluble hydroxides are sodium hydroxide and potassium hydroxide. The compounds barium hydroxide and strontium hydroxide and calcium hydroxide are marginally soluble. Most sulfide, carbonate, and chromate and sulfate salts are only slightly soluble. So let's see what does that mean, slightly soluble. Slightly soluble means that the tiny amount of solid that dissolves is not noticeable. The solid appears to be insoluble to the naked eye. So slightly soluble and insoluble, sometimes we can use both of them. It has kind of same meaning.